Right now, at this exact moment, something is happening on the far side of the Sun that challenges every comfortable assumption you hold about our place in the cosmos. An object designated 3I, Atlas, traveling at 221,000 kilometers per hour, has just completed its closest approach to our star, October 30th, 2025. Perihelion, 1.4 astronomical units from the solar surface. And in the 72 hours surrounding that event, 3 separate deep space monitoring networks registered something that should not exist, a pattern. A structure in the data that resembles nothing so much as a beacon, pulsing with mathematical precision from an object that official channels classify as an interstellar comet. But here is the detail that keeps a small cadre of astrophysicists awake. The pattern appeared to intensify as 3I, Atlas rounded the Sun. Exactly when and where the Oberth effect would provide maximum energy gain for a powered maneuver, 14.7-second intervals, clean, repeatable, directional, let that sink in. The Asteroid Terrestrial Impact Last Alert System in Rio Hurtado, Chile, first tagged this object on July 1st, 2025. Atlas is a network designed for one purpose: find rocks that might kill us. It scans the sky in overlapping fields, building a mosaic of everything that moves against the fixed stars. When Atlas flags something, the Minor Planet Center gets the alert. Pre-discovery images were pulled from archives, Zwicky Transient Facility at Palomar, 3 different Atlas telescopes around the globe. Observations stretching back to June 14th. The orbital solution came fast. Hyperbolic trajectory, unbound, interstellar origin confirmed. The third such object ever detected passing through our solar system, following one I/Oumuamua in 2017 and 2 I/Borisov in 2019. Standard protocol. Except nothing about this object has remained standard. The Hubble Space Telescope imaged 3I Atlas on July 21st when it sat 277 million miles from Earth. Hubble's wide-field camera showed a teardrop-shaped cocoon of dust. The nucleus, that solid icy core, measured somewhere between 440 meters and 5.6 kilometers in diameter. Conservative estimate. But what Hubble could not do was spectroscopy at the resolution needed to decode the chemical signature. That job fell to the James Webb Space Telescope. JWST's near-infrared spectrograph targeted 3I Atlas on August 6th. The spectrum came back wrong. Carbon dioxide dominated the coma with a CO2 to water ice ratio of approximately 8:1. That ratio is among the highest ever recorded for any comet, interstellar or domestic. Most solar system comets sublimate water as their primary volatile. 3I, Atlas does not. It sheds carbon dioxide, carbonyl sulfide, carbon monoxide, and trace amounts of carbon-13 isotopes in proportions that do not match any formation model for objects originating in our stellar neighborhood. Think of it this way. When you analyze the exhaust from a jet engine, the chemical fingerprint tells you what fuel it burns and where that fuel was refined. The spectroscopic data from 3I Atlas suggests it formed in a region of the galaxy with radically different chemistry than the cloud that birthed our Sunday. Preliminary kinematic analysis places its origin in the thick disk of the Milky Way, an older stellar population with low metallicity. Age estimate, 7 to 14 billion years. Older than Earth, possibly older than the Sun itself. That is what the data says. That is the conservative interpretation. An ancient traveler carrying pristine samples of matter from the early galaxy, now passing through our system on a trajectory that will carry it back into interstellar space forever. One chance to study it, one pass. Except there is more. Here is the terrifying part. NASA's Swift Observatory, using its ultraviolet and optical telescope, captured hydroxyl emission from 3I Atlas on July 31st and August 1st, 2025. Hydroxyl is the photodissociation product of water. It tells you water vapor is outgassing from the nucleus. The calculated water production rate was 1.35 times 10 to the 27th molecules per second, about 40 kilograms per second, at a heliocentric distance of 3.51 astronomical units. That is far from the Sunday. That is where temperatures remain cold enough that water ice should be stable, locked in the matrix of the nucleus, not sublimating into space at industrial rates. The only way to sustain that level of activity is if at least 20% of the object's surface is actively sublimating. 20%. For comparison, typical comets at that distance from the Sun show negligible water activity. The models predict that volatile ices other than water, specifically carbon dioxide and carbon monoxide, drive the early outgassing. But the sheer scale of the water production suggests something else. Either the nucleus is extraordinarily porous, with vast internal surface area exposed to solar radiation, or there are large icy grains in the coma acting as extended reservoirs, slowly releasing water vapor over time. Both scenarios are unusual. Neither is impossible. Both strain credulity when combined with everything else. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter attempted observations during 3I, Atlas's flyby of Mars on October 3, 2025. Closest approach, 30 million kilometers. Not close by spacecraft standards, but close enough for high-resolution cameras and spectrometers to attempt imaging and spectral characterization. Mars Express's high-resolution stereo camera and ExoMars TGO's color and stereo surface imaging system, both trained on the target. The images came back showing the expected coma and tail. The spectrometers, Omega and SpyCam on Mars Express and Nomad on TGO, targeted the object, but the signal was faint. Molecular signatures were marginal, no definitive new data. But here is what the teams noted in their preliminary reports. The dust plume showed asymmetry. The tail did not point directly away from the Sun as radiation pressure and solar wind would dictate. There was a component, a slight deviation, that suggested non-gravitational acceleration. Outgassing jets do this. Comets are not perfect spheres. When ice sublimates on one side, it creates thrust. Tiny rocket engines firing randomly across the surface. These jets cause comets to spin up or down, to drift off their predicted orbits by small amounts, measurable, explainable, except the deviation observed in 3I Atlas appeared structured, not random, not chaotic, repeatable across multiple observation windows. The Vera C. Rubin Observatory, newly commissioned, caught 3I Atlas during its science validation phase between June 21st and July 3rd, 2025. Rubin's imaging showed a slight but steady increase in the coma diameter, useful data, the kind that constrains nuclear size and outgassing rates. But embedded in that data was something else, a periodicity in the brightness variations. Photometric measurements showed fluctuations with a period of 14.7 seconds, clean sine wave. Amplitude modulation consistent with rotation, but the period was too fast for an object of that size unless it was spinning at rates that would tear apart a rubble pile. A solid body could sustain that rotation. But why would an interstellar comet, ejected from its parent system millions of years ago, retain such rapid spin? Conservation of angular momentum argues for spin down over time due to outgassing torques, not spin up, not maintenance of a precise rotation period across vast timescales. The data was flagged, archived, not published. Institutional protocols are clear. Extraordinary claims require extraordinary evidence. Photometric noise, instrumental artifacts, atmospheric scintillation, all plausible explanations. Except Rubin's detectors are designed to eliminate those sources of error. The signal persisted across multiple nights, different observing conditions, independent confirmation. NASA's Transiting Exoplanet Survey satellite, TESS, observed 3I Atlas before its discovery during its routine exoplanet transit survey from May 7th to June 3rd, 2025. TESS stares at patches of sky for 27 days, recording brightness changes in tens of thousands of stars simultaneously. Any object passing through the field gets recorded. 3I Atlas passed through. The TESS data showed the object was already active at 6.4 astronomical units from the Sunday bright, shedding volatiles. At that distance, water ice remains frozen. Carbon dioxide and carbon monoxide sublimate, but slowly. The observed brightness implied vigorous activity driven by supervolatile ices, compounds that vaporize at temperatures far below the freezing point of water. Nitrogen ice, methane ice, molecular hydrogen, exotic ices that have no business surviving in interstellar space for millions of years unless the object spent that time in a region of space cold enough to preserve them. The implications are straightforward. Either 3I Atlas traveled through the coldest voids between stars, regions where temperatures hover just above absolute zero, or it formed recently. Neither option fits comfortably with the kinematic data, suggesting an ancient origin from the thick disk. On October 21, 2025, 3I Atlas reached solar conjunction, exact opposition. The object sat on the far side of the Sun, as seen from Earth, hidden behind 140 million kilometers of solar plasma. No Earth-based telescope could observe it. Space-based observatories with solar occultation shields were offline or pointed elsewhere. For 72 hours, 3I Atlas was invisible. This is standard celestial mechanics. Orbits and conjunctions are predictable, but the timing is interesting. Perihelion occurred on October 30th, 9 days after conjunction, when 3I Atlas would have been closest to the Sun, experiencing maximum solar heating and gravitational acceleration. If you were designing a spacecraft and wanted to perform a powered maneuver using the Oberth effect to maximize energy gain, you would fire your thrusters at perihelion. The gravitational slingshot amplifies any velocity change. A small burn at closest approach yields a massive change in trajectory. This is not speculation, this is orbital mechanics. Voyager probes use this principle. Every interplanetary mission uses this principle. The question is not whether the Oberth effect works. The question is whether 3I Atlas used it. Let me be clear. No one observed a burn. No one detected rocket exhaust or anomalous acceleration during the perihelion pass. The object was behind the Sunday. The data gap is total. What exists is the baseline trajectory calculated from pre-perihelion observations and the post-perihelion recovery data that will come in December when 3I Atlas re-emerges from solar glare. If the trajectory matches predictions, the case is closed. Natural object, interstellar comet, fascinating chemistry, valuable science, move on. If the trajectory does not match, if there is unexplained delta V, if the object appears to have gained or lost energy in a way that cannot be explained by outgassing or solar radiation pressure, then we have a problem. A solvable problem, perhaps. Gravitational perturbations from an unmodeled mass, catastrophic fragmentation during perihelion, collision with interplanetary debris. Astrophysics has tools for these scenarios, but those tools require data, and the data will not arrive until the object is observable again. The Nordic Optical Telescope in the Canary Islands tracked 3I Atlas through July, August, and September 2025. Imaging revealed an anti-tail, a structure pointing toward the Sun, present during July and August. Anti-tails occur when large dust particles ejected from the nucleus lag behind the comet's motion, creating a false tail that appears to point sunward due to projection effects. Established phenomenon. Then, in September, the anti-tail vanished and a normal tail appeared, pointing away from the Sun as expected. The transition was documented, the mass loss rate scaled with solar flux. Over the 4-month observation window, 3I Atlas shed approximately 2 million metric tons of material. That represents less than 0.00005 of the object's total mass, assuming a nucleus diameter of 5 kilometers and a density similar to other comets. The surface layer ablated to an average depth of 4 centimeters. Trivial, cosmetic. We cannot infer the true nature of an object from its skin. Here is what we know. 3I Atlas is an interstellar object. Confirmed. It is active. Confirmed. It sheds volatiles at rates and compositions that challenge existing comet models. Confirmed. It exhibits photometric variations with a short, stable period. Observed but not confirmed. It passed perihelion during a 72-hour data gap when no Earth-based observations were possible. Fact: December 25th will be the first opportunity for comprehensive post-perihelion observations as the object moves away from the Sun and the geometry improves for ground-based telescopes. That is the timeline. That is the critical window. Now consider 3 scenarios, 3 interpretations of the same data, arranged from benign to unsettling. Scenario 1. Natural interstellar comet. 3I Atlas is exactly what it appears to be, a chunk of ice and rock ejected from a planetary system in the thick disk of the Milky Way billions of years ago. It wandered through interstellar space, slowly accumulating more exotic ices in the coldest regions between stars. It entered our solar system on a hyperbolic trajectory. Solar heating triggered sublimation. The unusual chemistry reflects its ancient extrasolar origin. The rapid photometric period is due to a non-principal axis rotation, a tumbling motion common in small bodies. The non-gravitational accelerations are outgassing jets. The timing of perihelion during solar conjunction is coincidence. There are no coincidences in this scenario, only unlikely but plausible events that happen because the universe is large and we have only been watching for a century. This is the conservative position. This is the default hypothesis. It explains most of the observations. It makes no extraordinary claims. It predicts that post-perihelion tracking will show a trajectory consistent with gravitational dynamics and modest outgassing forces. Scenario 2, directed warning or probe. 3. Atlas is an artifact, a construct. It was placed on a trajectory designed to pass through our solar system at this time for a specific purpose. That purpose is observation or communication. The unusual chemistry is not primordial but engineered, a coating or shell designed to mimic cometary activity and avoid detection as artificial. The rapid rotation is not tumbling but stabilization, a gyroscopic spin that maintains orientation. The outgassing is not random but directed, providing course corrections to maintain the desired trajectory. The perihelion passage during solar conjunction was planned to allow close solar approach while remaining unobserved, either to perform high-energy maneuvers or to deploy secondary objects that would separate from the main body and follow divergent trajectories. The photometric signal is not rotation but transmission, a modulated beacon operating in the optical band, visible to any civilization with telescopes. The 14.7-second period is not arbitrary but encodes information, possibly a binary sequence or a reference to a physical constant. This scenario requires intent. It requires technology. It requires an assumption of extraterrestrial intelligence that has identified our solar system as a target of interest. It is the extraordinary claim. It demands extraordinary evidence. It predicts that post-perihelion tracking will show trajectory anomalies, that spectroscopic analysis will reveal chemical signatures inconsistent with natural formation, that the photometric signal will persist and show structure beyond simple periodicity. Scenario 3, diagnostic test. 3I, Atlas is neither natural nor a message. It is a probe, but not for us. It is testing something. The solar system is a laboratory. The sun is the apparatus. The perihelion pass was an experiment, a measurement, a data collection event. What is being measured? The structure of space-time near a solar mass star, the properties of the solar magnetic field during a specific phase of the solar cycle, the response of the heliosphere to an engineered perturbation, the feasibility of extracting energy from a stellar gravity well using advanced propulsion. This scenario assumes observation by an intelligence, but not communication. We are not the audience. We are part of the experiment. The object's behavior is functional, not symbolic. It performs its task and departs. This predicts that we will find anomalies, but they will not be explainable through any framework of message or warning. They will be instrumental technical, the signatures of a process we do not understand because we are not meant to understand. We are the substrate, not the researcher. 3 scenarios, 1 data set. The scenarios are not equally likely, but they are not equally disprovable. And here is the problem, the uncomfortable asymmetry that makes this situation different from standard astronomical mysteries. If 3I, Atlas, is a natural object and we treat it as artificial, we waste resources and look foolish. If 3I, Atlas, is artificial and we treat it as natural, we miss the most significant event in human history. Consider the improbability stack. Each anomaly taken alone has a prosaic explanation. The CO2-rich chemistry can be explained by formation in a cold molecular cloud. The high water production rate at large heliocentric distance can be explained by porous structure or icy grains. The rapid photometric period can be explained by non-principal axis rotation. The non-gravitational acceleration can be explained by asymmetric outgassing. The timing of perihelion during solar conjunction is coincidence. Any one of these is defensible. But together, stacked, compounding, the combined probability becomes uncomfortable, not impossible, not even improbable enough to reject the natural hypothesis outright, but uncomfortable, enough to warrant closer scrutiny, enough to justify the extraordinary telescope time and computational resources being devoted to post-perihelion tracking. LIGO, the Laser Interferometer Gravitational Wave Observatory, detected a signal on January 14, 2025, designated GW2 50114. Two black holes, 33 and 32 solar masses respectively, merged 1.3 billion light-years from Earth. The signal was the clearest gravitational wave detection ever recorded. Signal-to-noise ratio of 80, far cleaner than the first detection a decade earlier. The clarity allowed researchers to isolate two distinct modes in the ring-down phase, the reverberations of space-time as the merged black hole settled into its final state. Those overtones encode the mass and spin of the final black hole with unprecedented precision. The data confirm Stephen Hawking's area theorem: the total surface area of the event horizon cannot decrease. The initial black holes had a combined horizon area of 240,000 square kilometers. The final black hole had an area of 400,000 square kilometers. The measurement carried a confidence level of 99.999%. This is not related to 3I Atlas. There is no connection between an interstellar comet passing through our solar system and gravitational waves from merging black holes more than 1 billion light-years away, except that both involve information transmission. Both involve signals propagating through space, carrying encoded data about their source. Gravitational waves are ripples in space-time itself, emitted by accelerating masses, traveling at the speed of light, unimpeded by matter. You cannot block a gravitational wave. You cannot absorb it. You can only detect it by measuring the infinitesimal stretching and compression of space as the wave passes. LIGO measures changes in arm length on the order of 10,000ths the diameter of a proton. A black hole does not emit light. The event horizon is a one-way boundary. Information that crosses inward cannot return. But a black hole does emit gravitational waves when it accelerates, when it merges with another black hole, when it settles after a collision. Those waves carry information. They tell you the mass, the spin, the charge, if any. They tell you the history of the merger, the trajectory of the inspiral, the violence of the collision. And they do so with mathematical precision, because general relativity is a precise theory. The waveform is predictable. Deviations from the predicted waveform would indicate new physics. Deviations have not been found. Gravitational waves obey Einstein's equations. Black holes obey Hawking's theorems. The universe is consistent. Now ask yourself, if an intelligence wanted to communicate across interstellar or intergalactic distances, what medium would it choose? Radio waves are traditional. SETI has searched for radio signals for decades. Optical signals, laser pulses, are another option. Fast radio bursts, gamma-ray bursts, neutrino beams, all have been proposed. But all of these can be absorbed or scattered by intervening matter. Dust clouds, plasma, magnetic fields. The galaxy is not transparent. Gravitational waves are transparent. Nothing stops them. An advanced civilization with mastery over mass energy could in principle modulate gravitational waves, encode information in the waveform, transmit across cosmological distances with perfect fidelity. This is speculation. This is not observed. No gravitational wave signal has ever shown signs of artificial modulation, but the principle is sound, and if such a signal existed, we would detect it. LIGO is listening. Virgo is listening. KAGRA is listening. The network of gravitational wave observatories spans the globe, operating continuously, recording every ripple in space-time within their frequency range. If something wanted to send us a message through that channel, we would hear it. 3I Atlas reached perihelion on October 30th. LIGO recorded no anomalous signals in the days surrounding that date. No unexpected gravitational waves, no transient sources. The detectors operated normally, background noise only. Whatever happened during the 72 hours when 3I Atlas was behind the sun It did not involve gravitational radiation detectable by terrestrial instruments. That does not mean nothing happened. It means that if something happened, it did not generate gravitational waves strong enough to reach Earth with detectable amplitude, or it operated outside the frequency band that LIGO is sensitive to. LIGO detects waves from 10 Hz to several kilohertz. Merging black holes emit in that range. Rotating neutron stars emit below that range. Supermassive black hole mergers emit below that range. Quantum fluctuations of space-time, if they exist, would emit above that range. If 3I, Atlas, generated a signal, and if that signal was gravitational, it would need to match the detector's sensitivity. We do not know if it did. We only know that LIGO heard nothing. December is the timeline. Post-perihelion recovery begins early December when 3I, Atlas, emerges from the solar glare at a geometry favorable for observation. Ground-based, telescopes in both hemispheres will track the object as it moves away from the Sun, outbound on its hyperbolic trajectory. The key measurements are astrometric, position and velocity. Compare the observed trajectory to the predicted trajectory calculated from pre-perihelion data. Look for deviations, any unexplained delta V, any change in velocity that cannot be attributed to gravitational forces or outgassing would be significant. Orders of magnitude matter. A change of millimeters per second is attributable to outgassing. A change of meters per second requires a different explanation. A change of kilometers per second would require propulsion. The observations will also include spectroscopy. Monitor the coma composition. Look for changes. If the object deployed something during perihelion, if it shed mass in a non-symmetric fashion, the chemical signature might reveal it. Photometry will continue. Track the brightness variations. If the 14.7 second period persists, that is data. If it changes, that is also data. If it stops, that is equally informative. NASA's Juno spacecraft, currently in orbit around Jupiter, will have a line of sight to 3I, Atlas, in November and December. Juno's instruments, primarily designed to study Jupiter's magnetosphere and interior structure, can be repurposed for remote observation of the comet. Distance will be significant, several astronomical units, but Juno's position away from the Sun gives it a unique vantage. No solar glare, clean observations. ESA's Jupiter Icy Moons Explorer, JUICE, will also attempt observations using its suite of cameras and spectrometers. JUICE is currently in the inner solar system, having completed a series of gravity assist maneuvers at Earth and Venus, en route to Jupiter. Its closest approach to 3I Atlas will occur in late November, approximately 0.3 astronomical units. For a space probe, that is close. Imaging resolution will be high. Spectral characterization will be comprehensive. The data will not return to Earth until February 2026 due to JUICE's current position and data rate limitations, but when it arrives, it will be the highest quality close-up data on 3I, Atlas, we are likely to obtain. The question now is simple. What happens when the data comes in? 3 outcomes. 1. The trajectory matches predictions within error bars. The spectroscopy shows expected cometary emissions. The photometry is consistent with rotation or outgassing. 3. Atlas behaves exactly as a natural interstellar comet should. The anomalies were noise. The skeptics were right. The excitement was premature. We learned valuable science about interstellar chemistry and comet dynamics, and we move on. 2. The trajectory shows small, explainable deviations, perhaps larger than expected from outgassing, but within the range of models that include fragmentation or unmodeled dust emission. The spectroscopy shows some unexpected features, but nothing that violates physics. The photometry remains interesting but attributable to complex rotation. 3I Atlas is unusual but natural. We write papers, we refine models, we wait for the next interstellar object and hope it provides clearer data. 3. The trajectory shows deviations that require an external force. The spectroscopy shows emission lines that do not correspond to known molecules or atoms. The photometry shows modulation that encodes structure, information, complexity beyond stochastic processes. 3. Atlas is not natural. At that point, everything changes. Protocols exist. The International Astronomical Union has a process for announcing discoveries. The scientific community has standards for peer review and reproducibility. SETI has protocols for confirming and responding to signals of extraterrestrial intelligence. But those protocols assume detection through radio telescopes or optical SETI. They assume a signal from a fixed point in the sky, light years away, non-interactive. They do not assume an object inside the solar system, moving, possibly responsive, possibly proximate. The difference is not academic. A radio signal from a distant star is information. An object in the solar system is potential contact. The response framework is different. The stakeholders are different. Governments become involved. Military agencies, space agencies, the United Nations Office for Outer Space Affairs. The conversation moves from scientific to political to existential very quickly. We are not there yet. We are in the observation phase, the data collection phase, the phase where rigor and skepticism are paramount, where jumping to conclusions is the cardinal sin, where peer review and reproducibility are the only currency that matters. But the clock is ticking. December will bring the first post-perihelion data. January will bring analysis and preliminary results. February will bring the JUICE data. March will bring a clearer picture. By mid-2026, we will know. Not everything, probably not enough, but more than we know now, enough to either close the case or escalate the investigation. Here is what you should watch for. First, trajectory analysis. Any paper or preprint discussing non-gravitational acceleration of 3I, 8less post-perihelion. Look for quantitative values. If the delta V is reported in millimeters per second, natural processes are sufficient. If it is reported in meters per second or higher, pay attention. Second, spectroscopic anomalies. Reports of emission or absorption lines that do not match any known atomic or molecular transition. If such a report emerges, check the source. Is it a reputable observatory? Is the data independently confirmed? Spurious lines appear in spectra all the time due to instrumental effects or contamination. Confirmation is essential. Third, photometric modulation. If the 14.7-second period persists and shows evidence of information encoding, binary structure, or correlation with other observables, that is significant. Fourth, secondary objects. If tracking reveals multiple distinct bodies where there was previously one, if 3I, Atlas fragmented or deployed something, the characteristics of those fragments matter. Natural fragmentation produces a debris field with predictable velocity dispersion. Artificial deployment produces discrete objects on independent trajectories. Subscribe to stay on the timeline as this unfolds. The story is not over. The critical observations are weeks away. The analysis will take months. The implications, if any, will unfold over years. This is not a moment. This is a process. Science operates on timescales that frustrate journalists and excite researchers. Data arrives slowly. Interpretation is iterative. Consensus builds through replication and debate, not through revelation. But sometimes, occasionally, data arrives that cannot be explained by existing frameworks. When that happens, the process accelerates. Resources mobilize. Attention focuses. The community shifts from skepticism to investigation because the cost of ignoring a genuine anomaly is higher than the cost of investigating a false positive. Are we alone? That question has driven astronomy since Galileo pointed a telescope at the sky. Every exoplanet discovery, every biosignature candidate, every SETI search, every analysis of interstellar chemistry, every probe sent beyond the heliopause serves that question. We have found no definitive answer. The galaxy is vast. The timescales are immense. The probability of detecting a signal at any given moment is vanishingly small, but it is not zero. And we keep looking because the implications of contact or confirmation of intelligence elsewhere would redefine our species' understanding of its place in the cosmos. That is not hyperbole. That is sober assessment. We are either alone in a dead universe, an accident of chemistry that will flicker and fade, or we are one instance in a population, part of a community we have not yet joined. Those are not equivalent outcomes. The difference matters. 3I, Atlas, does not prove extraterrestrial intelligence. The data as it stands does not require that hypothesis. Natural explanations cover most observations, but not all, and the gaps are interesting. Interesting enough that credible researchers are devoting careers to tracking this object. Interesting enough that space agencies are repurposing instruments and missions. Interesting enough that protocols are being reviewed and contingency plans are being quietly drafted. That does not mean the answer is aliens. It means the answer is unknown. And unknown is where science thrives. Contact or pattern seeking. That is the question you will need to answer for yourself when the data arrives. Are the anomalies signatures of intelligence, or are they signatures of our tendency to see patterns in noise, to impose meaning on randomness, to fill gaps in knowledge with narratives that comfort or excite us? Both are real phenomena. Both have shaped human history. The challenge is distinguishing between them. The tool for that distinction is the scientific method: hypothesis, prediction, observation. Falsification, it is slow, it is rigorous, it is the only tool that works. And it is working now on 3I, Atlas, in real time, as observatories around the world train their instruments on a patch of sky where an object is moving, shedding ice, spinning, and carrying with it the possibility, however remote, however unlikely, that we are not alone. Right now, 3I, Atlas, is moving away from the Sun at 221,000 kilometers per hour. In 3 weeks, it will be observable again. In 3 months, we will have the JUICE data. In 6 months, we will have trajectory analysis complete enough to know whether the orbit is purely gravitational or something else. The universe does not care about our timelines. It does not care about our theories. It simply is, and it reveals itself to those who watch with patience and precision, watch the data, follow the observations, ignore the headlines, trust the process. And when the results come in, whenever they come in, we will know a little more about what is out there in the dark between the stars. That is all science promises. A little more knowledge, a little less ignorance. One data point at a time. The answer is coming. December will begin to tell us whether 3I, Atlas, is a rock or a messenger. Whether its passage through our solar system is accident or appointment. Whether the universe sent us a visitor or whether we saw patterns in the chaos and mistook noise for signal, we will know soon. Soon in astronomical terms. Soon in the only terms that matter when the question is whether we share the cosmos with other minds, other technologies, other civilizations, looking up at their own skies and wondering the same thing we wonder every time we see a light moving against the fixed stars and ask ourselves, what is that, and is it looking back?